Okay, so this is hole 3 on planet 1. It says observe the relationship between velocity and acceleration. So this is really where we're starting to scaffold up into vectors. We already got exposed a little bit to the components of velocity, and velocity is a vector. But in the second planet, we're going to be dealing with a lot of new forces, which are all vector quantities. And so comparing velocity and acceleration, it's going to distinguish between a vector and a force, which is a vector. So let's go through. Okay, so I'm going to load up my hard shot. I have no atmosphere, so I'm going to stay on the 50-degree wedge. I'm going to go to the side view. Now, we have an interesting thing on this hole actually that's being brought in, and that's these two little circles right here. So this one right here with the +1 is a mulligan, if I want to aim for that, and will give me an extra shot in case I mess up. And this yellow lightning bolt is an energy recharge. And you'll notice that when you start the planet, you don't have your full energy battery completely filled. And your robot in between turns will replenish some of that through his solar panels that he works with, which is changing the solar energy from the sun into chemical potential energy that's stored in the battery. So actually aiming for this will, at the beginning, make me hit a lot farther for the second shot, which I am going to try to aim for. Now we always have to account for the roll distance after the shot, which has a lot to do with the friction in the shot with the ball. So let's see how this goes. I'm going to try and hit it. And that bounced it clear off. We didn't get it. One of the things that you can do if you want to isolate a particular visual for a student is you can go to the pause menu and you can look at the in-flight visualization. The visual for hole 3 in planet 1 is a graph that on the left side will show the acceleration and on the right side will show the velocity. Remember, the question asked us to see what the relationship between the velocity and acceleration is. And this is actually, from the equation, something you'll get once you get into calculus, but if kids aren't too familiar with it, it's that the velocity is a linear change because, again, we only have gravity pulling down on it, and when the velocity is changing, only the vertical component is changing. So we will get a nice line. And when it crosses over the 0 axis is when it reaches its maximum peak and it's starting to descend down. The acceleration, you'll notice, is just a horizontal line, which makes sense because in calculus, the derivative of a second-order equation, of a first-order equation, is just a horizontal line. It will just be a number. And this is sort of the deeper relationship with the facilitation can kind of bring in, and if the kids are comfortable with calculus. But on the other aspect of it, they can just notice that the velocity is a line with a slope, and acceleration is a horizontal line with no slope, a slope of 0. Okay, so I'm just going to get through this real quick because that's basically the pitch about the two graphs. Oh, sandpit, no, yay. Let's see, 151 meters, 250 got me 400. Let's see. Oh, that's going to bounce right off. Right there, that looks good. For our third challenge on the third hole in planet 1, it asks what is true about the relationship between the vertical velocity component and the acceleration after the golf ball is hit. And what we noticed from the graph, what we knew, is that a horizontal line represented the acceleration as time was passing, and a linear line, just a line with a slope, was talking about the vertical velocity component. So we need to see that. Let's look at our option. When the velocity is changing linearly, the acceleration will be constant. And this actually, it was lucky that it was front and center, but this is actually what was occurring. Acceleration being constant means unchanging, there's no slope. Changing linearly is implying that it has a slope and it's a line, much like what we saw. So I'm going to pick this one. And actually, speaking some of these outliers as well, they are really trying to call upon the misconceptions through research that we found that really try and address what kids are confusing this by. So they may not know exactly what is affecting acceleration, what is affecting velocity, and how they have to relate to each other. And so this actually is a great opportunity on this whole for teachers to come in and facilitate and clarify that misconception. So I'm going to install this on my robot, and it's correct. Of course it's correct. I wrote that question.